Hello, it's Duncan. I'm back, and once again we're looking at the Gilded rows refactoring kata, converting it into Kotlin from Java, and then looking at how we might make it more idiomatic Kotlin, should we say. I think before we go on, it's worth looking at what we have achieved so far. So on the left here, this is the Gilded rows class as it was. And you can see that all the work happened in this update quality method, and it was confusing to the least. It took us a long time to sort of tease it apart. Now, Gilded rows on the right, then the current version, very much simpler. It's now in Kotlin. That's not really the reason it's simpler. It's simpler because we're now delegating all of what happened in update quality to item update. Item then, that used to look like this. It used to be Java with some public fields, a constructor and a toString. Item still looks like that in Kotlin. It's an open class with some now properties and a toString, but we've now got subclasses of item where the way that it's updated is in a what's called template method in the base class here, and then there are default behaviors about aging and degradation and saturation, and then different subclasses are able to create different express different versions of these behaviors. And we don't see it here, but in the test, then instead of creating always just items, we're now sometimes creating base items, sometimes creating specific types of items in order that this polymorphic behavior can kick in. Okay, that's a little recap. Let's get on and find out what we can make better next. So item is where all our complication is these days. Looking at item, we now see that this update method does age, degrade and saturate, but these functions don't really enforce anything on the subclasses. So age could reduce the sell-in time, not reduce the sell-in time. It could change the quality, lots of things, because these protected functions just mutate. So they're not really enforcing any constraints on the subclasses. And it's difficult to see from here what they do. We might imply from the names, but that's all we've got really. We have to look into subclasses to see what they're actually doing. So I wonder whether instead of mutating the objects at these points, these functions could return the values that they wanted to retain. Effectively do a calculation that the base item here can apply. And to see this, we'll think, well, what is age doing here? It's actually reducing the sell-in by 1. So what this is the amount of aging, if you like. And let's not do whatever that is. And looked at from that perspective, then sulfurous has aging, but its aging is 0. So let's just take that and move that down in sulfurous as well. And that is 0. And I've missed an R, it turns out. Aging is private here, so we're going to make this protected and open. Okay. Now this should pass our tests. Okay. So now the beauty of this is we can inline this age function. Sulfurous has an age function now, but it's not used. This runs. And now subclasses can change the value of aging, but they can't change what it means to age. What it means to age is that we reduce the sell-in by a certain amount. This also means that we can look at base item and see what this part of our algorithm is doing without having to look down into aging into age as we had before, in order to work out what these different parts mean or infer from their names. So we're going to commit that. We're going to say this is convert or replace age with aging, and not a bad place for a little break. So let's then look at degradation in the same way. At the moment, degrade updates quality directly, but what we want to do is return the quality that it should degrade to, or maybe return the amount that it should degrade by. I don't know which at the moment. So I'm going to try to sort of tease that out of this with the refactoring, maybe see how it goes. So my thoughts are maybe if we introduced a variable here that was just a let's call it a var, and we'll call it quality, and we'll set that to this.quality. Then we would be using that here, so that's what we're setting, and then we could say quality equals, well, in fact, this dot quality equals quality. And so what we're doing is we're calculating the amount we want to change it, and then we're changing it. And so this then could become the amount of degradation. Returns an int. And ideally we would pass in the current quality and probably the sell-in as well, because this depends on these two things. It depends on this quality and the sell-in. So we'll make a parameter out of sell-in. And we'll make a parameter out of quality. And now we can see that when we degrade, we call this method to find out what the degradation is, and we set the quality to it. So we could inline that first of all, and the quality is just that. Okay, it's replaced this dot sell-in with this dot sell-in, but we want to talk to that. That's all good. And having seen this, well, we could just sort of cut out the middleman now and say return return the thing we want quality to be. So we're going to return quality -2 or quality -1. Don't need that. Don't need that. And now lift the return up the if and convert to expression body. Personally, I kind of like whens here because they format a bit better. There we go. So let's just check that still works. And now this is the thing we might want to override, so we'll make it protected and open. So what we've done is we're going from methods that mutate to methods that calculate. Okay, so in sulfurous, what does degradation mean? Well, in sulfurous, degradation doesn't happen. Here we're returning at the moment the amount, the thing that we want quality to be. So in sulfurous we want quality to remain the same as in terms of degradation. So that still passes. And again, we could refactor the current methods, or we can just basically work out the answers, which are like this. Small problem of that bracket. Still passes the tests, and the same thing here. So we'll take this. So we've gone from mutate to calculate. And what we want to return here is the amount that we want to change the quality by. No, the amount that we want the quality to become. So that's all good. The only problem is that this wants to say that it returns an int, I think. don't know what IntelliJ's problem is. Returns are not allowed for functions with an expression body. Oh, so obviously, yes, we don't want to return it. That is just what it is. Okay, splendid. So, having done that, degrade is not a thing we want to override, and we could inline degrade in our superclass, in the base class. This now sort of begs the question, should we, you can see what we're doing is we're returning the amount that we want to set quality to. Should we return the amount that we want to degrade by? So at the moment we're saying this is, we want to set quality to quality -2, but we could say we want degradation returns -2 in this case. I think that feels a little bit more natural to me. In the way that we subtracted aging from selling, it would at least be the same sort of pattern. There might be a nice way to refactor it, but I'm just going to suck it up, and I'm going to say the quality is the quality minus the degradation, and I'm going to go through these and say that I've said minus degradation here, so these want to be 2 and 1, and everything else will break until I fix them all. The amount that we want to subtract from quality is 0 for sulfurous. The amount that we want to add is the amount we want to subtract is -2 and -1 because Brie gets better. This again would look nicer as a when, especially if that was formatted up there, and that would drop everything in there. And then in the case of the pass, we want to, when the selling is less than 0, we want to reduce the quality by some amount, and the amount we want to reduce it by is the quality. So that will take it down to 0. This is, and these are increasing, so oddly, but that kind of feels right. We are returning a negative value for the degradation because we're not actually degrading, we're going the other way. And again, the whens seem to nicely format up here. Like that, brings everything over to the left. Okay. Saturation, should we do the same before we take a little break? I suppose we could. So in this case, I think we might just go through and edit. Let's give saturation. Let's pull the same stunt here. Let's say if we had a protected open fun, and this is going to return what we want quality to be rather than what we're going to subtract from it. Saturate, given some quality, which is an int, this is going to want to return an int, and it's just going to return what this returns actually, but it's going to return, well, not, yes, it's not going to mutate, it's not going to return what this returns, it's going to return 0 or 50 at either end. Fix this up by making that like that. What is its problem here? We don't have an else. Well, in other cases we want to return the quality, we don't want to change it. So that's what saturation means. What does saturate do? Well, it now says quality equals saturate. Saturation applied to the quality. Get rid of this, see whether that works. It does, and we know the only thing that overrides saturate is sulfurous, and so we can take this saturation and use it as the basis for sulfurous. What does no saturation mean? it means that the quality just stays the same, so return quality. Okay, check that, still passes the tests, and it does. And now again we can inline saturate so that we can see what that does in place. And now having done that, we can inline again so that here we are mutating the quality and we're mutating it again. That seems a shame. Inlining when you're doing this doesn't work so well, so we're just going to apply saturation to the result of subtracting degradation from the quality. And this is one of the problems with mutating things, is it forces us to think about what's done before and what's done afterwards, whereas now we're in the world of calculations. We can always make calculations that always answer the same thing. That looks like a good place to take a little break, so we're going to commit and we are going to say replace degrade with degradation and saturate with saturation. Okay, so just to recap, what we've done here is we've said let's change these policies from something that mutates our object to something that calculates how much we want to mutate our object, and then the mutation is happening in the update and the calculation is happening in the subclasses. Right, let's have that little break now. Right then, to be honest with you, I think this may be as good as an object-oriented solution gets. Oh, I haven't said that, we still have the saturate method there, which is that we have subclasses which express their different strategies, and we're communicating well what happens in when we update an item. What we're going to look at now is how a functional programmer might look at this problem, and a functional programmer wouldn't subclass. So we're going to look at how to migrate to that form. A functional programmer probably wouldn't mutate either, but we're going to address mutation later on. Before I go on, just let's amend commit that last. Okay, so we've got these policies, if you like. There's aging, degradation, and saturation, not necessarily the right order. So let's address aging first, as it's simple. Instead of having a method to override, we want to have a function to call. And what we're going to do in order to achieve that is we're going to make this an open val. So it's a value. And if we just swap these around like this, then what we have now is we have a value that is aging, and its type is a function from nothing to int. Basically, it magics a number out of the air, which is the amount we're going to age by, and in the base class it's defined to be 1. Now we can, because this is a function type, we can call a function on it. We can call it as we do here. If we run this, we will probably break Sulfurous. Yes, we've broken Sulfurous, because Sulfurous says, look, I override this function, and we don't have a function anymore, we have a value to override. Now, values are kind of functions, but let's not worry about that for now. Let's just say, let's take this val and say we'll do the same thing in Sulfurous. So our aging, it's a function that returns 0. Now that is overriding the right thing. We're returning 1 in the top case, 0 in the second case. Okay. Now this now allows us to play a game where we move this thing to be a constructor parameter. IntelliJ hasn't quite done the right thing there, but that's all right. Now that's a constructor parameter. In the case of sulfurous, we can pass it up to our superclass. So what we can do is let's go over here. We'll put these on separate lines so we've got some space, and we'll say, actually, let's just move that up. We're not going to override it now. We're going to pass it up to our superclass, our supertype. Now we have a problem because base item now takes an aging parameter, but it's defaulted and our Java code doesn't know how to default that. I think we're just going to go ahead and convert this to Kotlin to solve that problem. That's all right. Would be if it compiled, but that just seems to be a little bit of a brain dead change, and now we're working. So now base items have this default way of aging that is in their constructor, and sulfurous can change that by passing up a function rather than overriding a method. This looks a little bit of a strange form here, so we can convert it to a lambda expression. That lambda expression is return 0. Here we can do the same thing and say that's a bit of a strange one. Let's make that a lambda expression. That lambda expression is return 1, and it turns out we don't need the arrow there. Okay, this now doesn't need to be protected. In fact, it can be private because nobody has to override it. It's passed up from the places, in this case sulfurous, where it's different. Okay, I think that's probably a good time to checkpoint this. So we are now saying replace aging with a function parameter. Now in the case of aging, when we look at this, we could actually just pass it, rather than pass a function, we could pass an amount that we would age by every time, and we didn't see that actually, interestingly, in the previous version, in the subclassy version. But let's leave it as it is for now. Gives us the opportunity to have more sophisticated aging strategies than just subtracting a number. Now we can go ahead and do the same thing for degradation and saturation. So let's practice that. This is an open fun, wants to be an open val, which is set to be a function type. We need to fix up the subclasses to do the same thing. But because we'd already done the work to not mutate our item, but instead just return what we wanted to set our quality to, the amount we wanted to change our quality by, these are all rather easy to change. Run that. Passes, splendid. Now we're going to do the job of saying make this move this to the constructor. It's all a little verbose, so let's say we want to convert to a lambda expression, reformat that a little bit, and now we'll come down here and say this is our aging, we want to move degradation up. Just pass it up here. So now this is I said it, isn't it? Right. And note the interesting thing is that this code here, the update didn't have to change because we got it into a nice shape before we got here. And our subtypes now pass up the strategies they want to apply to the aging and the degradation and saturation. So this is replace method overriding with function parameters. And let's commit that. Okay, so now we have subclasses that actually don't subclass anything. They only pass a strategy up to the superclass. So these all have empty bodies. And if they don't do anything, then they're not worth keeping. So all we need to do is to arrange to call this base item constructor when we would have been creating an instance of pass, and so on. Now luckily in Kotlin, and we've just converted this hopefully, the syntax for calling a constructor and calling a function are the same. So what we can do is we can go over here and starting with sulfurous, we can say if this was a function, then it would return a base item. This was a function. Instead of defining what a superclass looked like, a subclass looked like, it would return a base item. And same here. And if we run that, everything is happy. And so now we're in a position where we only have we have no subtypes of base item. So we can remove that. And the only reason we have any subtypes at all is because of our rule about not modifying item. And we'll go back and break that rule a bit later. So we're going to commit this, and this is remove base item subtypes. There are 6 warnings. These are around shadowing the names of parameters because there's a parameter here and they have the same name here. I think we're going to not worry about that for now. Okay, whilst we're not worrying about that though, this is a bit ugly, it's a bit cryptic. What we can do is we can create a namespace here. We're going to call it aging. And in our aging namespace we will define what normal aging looks like. A normal aging, so we say aging standard maybe. So standard aging looks like that, and if that's the case, then in base item this is standard aging. The only other subclass of aging we have is in sulfurous. What we'll do is just duplicate that and say there's this none which returns 0. There's our policy, and this is saying aging dot none. Sort of tidies things up a bit. We can pull the same stunt with degradation. So this would allow us to refer to these things by name and reuse them in different places. So this is degradation, if I get it right. Okay, that's a good place to be. So this is now extract common policies. I think that will do for a name. Three warnings, again shadowing. Shall we go and fix those now? Fewer of them. This is sell into current sell in. We had the same problem here. Could have done better there, couldn't I? go to the beginning of that current cell in. Same thing here, just to differentiate between the two names. Still passes, commit it, and that's a good place. Now we're in this place, it's worth remembering that we were actually sent to make a change. So we have refactored this a great deal to make space for the change, to make the change a simple change. So let's try and remember what the change was. And the change we're supposed to be making is we have recently signed a Conjured supplier of Conjured items. Conjured items degrade in quality twice as fast as normal items. So we could have implemented degradation with our object-oriented solution. That would have been fine. We could have subclassed, we could have had Conjured, we could have another subclass, we would have introduced another subclass where the degradation was a different policy. But now we're in maybe quite a nice place to do it. So let us go off to the test fixture and say, if we got this right, this would be Conjured. So we need to tell it that there's a slightly different thing. Conjured doesn't exist yet, so let's say create a function Conjured. Yes, let's not worry about all those names yet. We don't want this to be in here, we want it to be an item. Okay, not private. Conjured items then are going to be very much like base item, in fact very much like Brie, but where Brie well, let's just take this, shall we? So, reminding ourselves, Conjured items degrade twice as fast as normal items. How fast do normal items degrade? Let's go back and look. So normal items degrade this quickly. So let's just take that for now and copy it and paste it into here. And we'll say twice as fast means when it was 4, when it's 2 it was now 4, and when it was 1 it's 2. And we don't care about that. If we run this, we can now look at the effect on our test. Our test fails because we have actually changed the behavior. And we'll have a look at what actually happened. So Conjured manna cake went from 6 down to 4, previously 5, down to 2, previously 4, down to 0. Okay, so that looks like the behavior that we think we want. We're going to copy that from here, go back to the test fixture and say that we can now this is now the version we want. Lost the trim indent there, a little bit irritatingly, but let's make do with that for now. So now we've changed the behavior. We have fixed the test to show the new behavior. Let's commit that. So this is now implement Conjured. One warning, name shall it set in. Rename current cell in. Commit. Commit. Okay, take a little break. Could we do better? Well, I think we could, because the spec didn't say that conjured items degradation is 4 or else 2. It said current items degradation is twice that of normal items. So can we actually express that? Can we say that our degradation here is degradation dot standard times 2? Because that would mean that if we change what standard degradation means, we would change what conjured items did as well. Interesting question. So let us go and say, how could we make that happen? And this says, yes, we could create an extension function. And that would be on a function type that was int, 2 ints to an int. That's not right. Create that extension function. And the target class for interface function 2, I suspect that's okay. And now this is the multiplier. And the multiplier is an int. And this returns int and int to int. And for some reason, it returns a function that takes 2 ints and returns an int, but it also should be defined on a function that takes 2 ints and returns an int. So a little bit over generic. And that needs to go there. Okay. Now, what should this function do? It should call the initial function with its 2 parameters, which we don't have here. So this would be, let's call it P1 and P2. So it should call this, the receiver, this function with P1 P1 and P2. Need to put the equal sign in there, define it, and then it should take that and multiply it by the multiplier. Let's just see whether that passes our test before we go and tidy it up. And it does, which is really rather nice. Can we make this look nicer? Well, we can at least make it public. We could change this probably to a function type. Or we can specify an explicit lambda signature, and if we do, then we can remove this. It's all looking a bit wordy. That will do, I think. Still passes its tests. That's good. And while we're here, then we can note that Brie actually, we've got a special case here for Brie. But we could replace that with degradation dot standard times -1. And that works. So this shows how we can compose functions nicely. We can build a sort of language around what our policies are. Should we have made that last step? Aged Brie increases in quality the older it gets, but it doesn't specify how, interestingly. So we might want to go back to our customer and say, is Brie actually the negative of the standard, or is it defined to be increased by 1 and increased by 2? We don't know. I'm going to leave this in place because it's kind of cool. Okay, so that looks like another great place to check in. And this, having implemented Conjured, we are now add times for degradation. Want of a better phrase. Good. So what we have now is quite a nice functional solution. We are expressing our policies with function types. We have higher order functions. Everything is calculations, except that we are still mutating our item fundamentally, and we still had this subtype of item, which is base item. I think now we have built up a bit of rapport with our customers. We might go ahead and change item and change this to a more immutable solution. So let's think about what that means. First thing I think we'll do is we'll just collapse item and base item together. Think of a nice way of doing that. There are various sort of pull-up things, but I wonder whether we might just let's see whether we can do that. We say refactor this, and we've got pull members up. So we want to pull aging, saturation, and everything up into our base class, into item. That's all good, except it just hasn't worked. Never mind. Let us take these things and cut them out of here. We're just going to do this by hand. So it pulled up the update method, but didn't pull up these properties. Once you've done this, base item is empty, and we'll just go and fix up the consequences of that nastiness. So first of all, let's fix up here, in here. So let's say we've got some base items. Let's select all those. Has that multi-select worked? It has. So these just want to be items. And now all of our items are base items, so we can get rid of this. Well, all of our base items are items, I suppose. We've collapsed the hierarchy. And I don't know what this test was ever doing for us, so I'm going to delete it. Okay. So now we have item, which is an open class, but doesn't need to be. So we just shuffled everything up, changed item, but that's all good. Okay, let's commit that. So what we've done is we've merged item, base item, into item. And that's simplified, as we said. This is a bit of code here, so that's not a bad thing. Commit that. We've got one last major thing to do, which is to address the mutability of item, but I think that's going to be another episode. So just before we go on, let's have a little tidy up so we're in a nice place. I think one good place to tidy up would be currently Gilded rows takes an array of items, which is irritating. So let's make that a list. I don't think that should affect much, and it would allow us to say list of item here. Remove that. Just a little bit more Kotlin-y. And then item is currently, well, it's in a nice, it's in one file. We've got all these subtypes and so on. So I wonder about taking these places where we're actually creating individual items, these ones, and moving those functions. I'm going to cut them from there for now and say, let's have a new Kotlin file which we'll call items, and we'll make it a file, and we'll just add git, and we'll just put these in here. So these are our constructors, the things that construct items, and then these other things, they could stay here, or it's a bit irritating scrolling up and down all the time. So maybe we will take these and cut them out of here, and new Kotlin file, and I think maybe policies or something like that. Add that and paste that in there. That just lets us navigate without scrolling up and down too much. Item is now nice and clean. And to recap what we've done in this video, we took an inheritance hierarchy and we have flattened it, so we've replaced inheritance with composition. So we're now composing items out of these strategies of aging, degradation, saturation, policies, another word for that. We've used function types to express those. We have collected them together in places, and we've used constructor functions rather than constructors of subclasses to build items that are correctly configured to behave as we want. So the last thing we want to address is this mutability here, and we'll look at that in the next and final installment. See you there.